Today our main focus is Mathematics 1510, October-November 2014, question 3. Let us start. This is the actual question paper. We can see we are given two functions. The first one is parabolic function, the second one is absolute value function. Let us go straight to the scenario and also look at the questions. Now the scenario is saying the sketch shows the graph of function f and g, where f is defined by, so we can see that the first graph or function is defined by this equation, and we can also see that this equation is a parabolic, and g is defined by, we look at the second one, which is our absolute value function. Now furthermore, the scenario is saying the graphs of f and g intersect at point, so we are given these points. Looking at the graph or the diagram, we can see these are the points which they are referring to. The graph passes through the point, or the graph of f passes through the point 0 maps 0. So this is the point whereby our graph f passes through as well. Now 3.1, determine the values of k, p and q, and then write down the equation of g. So the equation of g, we focus on the absolute value graph. We need to look at all the given information. Now in this case, we can see that we have these 2 points which is on top of the absolute value graph, and we can also see that this point is our vertex or the salient of the absolute value graph. And then we also have another point which is there. We can also see that the absolute value graph, it has 2 X-intercept. Okay, now this is the given information we have. We are going to use it to actually calculate or determine the values which are required by the question. So looking at this equation, so the question requires us to determine the value of k, p and q, and it's for 4 marks. So let us get to it. Looking at this, we can see that I actually isolated the absolute value graph and the parabolic graph so that we can focus on the main question here. Now we are given this diagram, and then we definitely know that this vertex, it's actually represented by p and q from the general equation. So we can go ahead and plug in we know that the value of p is 1 minus 3. So without further determination or calculation, we know that the value of p is equals to 1, and the value of q is equals to -3. So we are left with k. So if we have the vertex of the absolute value graph, we can just, or if we have the vertex of the absolute value graph and another point which is on top of the very same graph, we can simply use that point to determine the value of k. We all know that the absolute value graph, we have 2 different types of graphs. Actually, we have 2 parts. The first part is the one whereby the gradient is negative. Then the second one is the second part whereby the gradient is positive. So we can see that the point of which we are talking about is this one, and it's on top of the positive part of the absolute value. So in this case, we are going to consider the positive absolute value graph, since that point is on top of the positive part of the absolute value. So we know that the order pair is x maps y. So where we see x, we can substitute by this. Where we see y, we substitute by this. So we can see that this is y, our output. So we are going to substitute by 5. And then we are going to have k. And then we have x, it's 5 minus 1, negative 3. So from here, we can transpose this to the other side. We are going to have 5 plus 3, it's equals to, we multiply this and this. We have, before we multiply, let us actually solve inside the bracket. 5 minus 4 is actually, 5 minus 1 is 4. So 4 multiplied by k, we have 4k. And then from here, 5 plus 3 is actually 8. And then we have 4k. Remember, we are solving for k, so we divide both sides by 4. So this will result into 1. 1 multiplied by k, it's k. And then 8 divided by 4, it's actually 2. So this is the value of k. Then from here, the question is saying we must write down the equation. So this is the equation we have for the absolute value graph. We are done with the first question. Let us continue. Going back to our question paper, let us look at 3.2. 3.2a says determine the x-intercept of the graph of G that lies between. So let me actually erase everything here. So we are looking for this point here. This point here. As you can see that it lies between 1 and 5. So we have two x-intercepts. This is the first one, this is the second one. So the question specifically give us the interval. It's saying from 1 to 5. So this is the x-intercept we are looking for. Let me use the previous diagram, and we actually need to explain this. So like I said, we have two different types of parts, or two parts of absolute value graph. Now the question, it's asking us based on this point. So it means we are going to consider the positive part of the absolute value graph again. So this simply means that we know our equation. Our equation is g of x is equals to 2x minus 1 minus 3. In this case, we need to consider the positive absolute value graph part, because when we look at the diagram, we can see that from here to here, it's where the gradient is positive, so we consider that part. So we don't have to change anything. For solving for x, we let y to be 0. So this is our y, it's 0, it's equals to 2x minus 1 minus 3. Transposing this to the other side, we have 2x minus 1 is equals to positive 3. And then from here we have 2x minus 2 is equals to 3. And then we have 2x is equals to 3 plus 2. Then from here we have 2x is equals to 5. We divide both sides by 2. Then this will resulting to 1. 1 multiplied by x, it's equals to 5/2. So in most cases, I represent this in a coordinate form because x-intercept it's actually a coordinate. So this is the answer. Let us quickly move to the next question. We have 3.2b. It's saying use symmetry to determine the other x-intercept. We can use a distance equation, or we can simply use an average equation. For 3.2b, we need to look at the symmetry. Now, when you talk about the symmetry, it simply means that the distance from here to here, it's equals to the distance from here to here. So we can take it as we are looking for, actually this is the midpoint, and then this will be our one of the x coordinates or one of the coordinates, and then we are looking for this one. We have this, and then we are looking for this one. We can just use this equation, x of the turning point or the salient, it's equals to x1 plus x2 over 2. So this will be our x1, this will be our x2, this will be our xtp. So we have this, we have this, we are looking for this. We can simply substitute. We have 1, it's equals to x1 plus, let me actually create some space. Oh no, it's actually 2. Okay, so we have 1, it's equals to x1 plus 5/2 divided by 2. And then from here we can just multiply both sides by the number causing the fraction. This will get rid of this, and then we are left with 2 multiplied by 1, it's 2, and then we have x1 plus 5/2. From here we can transpose this to the other side, or we can continue multiplying by the number causing the fraction. So multiplying both sides, we have 2, 2, 2. This will get rid of this, and then we have 2 multiplied by 2, it's 4, it's equals to 2x plus 5. Transpose this to the other side, we have 2x, it's equals to 4 minus 5. We have 2x, it's equals to -1. We divide both sides by 2. So our other x-intercept, it's actually -1 over 2 maps 0. You can just figure this out without further calculations. As you can see, the mark allocation is 1. Our next question, which is 3.3, determine the values of a, b, and c, and then write the equation of f. This is our parabolic graph, which is graph f. As you can see that when dealing with questions, you only focus on the graph or the function which the question is based on, and also look at the given information in order for you to answer the question. You simply isolate any function which is not based on the question, and then you focus on the one which we actually want to answer the questions. So in this case, we can see that we have this parabolic graph, and then we have 3 points. Before we continue, you should know that in this form, we know that we have different types of general equations for parabolic graph. In this form, the value of c is the y-intercept. It's actually where the graph touches the y-axis, since this is y and x. Now in this case, you can see that the graph is actually touching x-axis and y-axis at this point. What is the value of y in this case? It's 0. So before calculating or determining other values, just know that c is equals to 0. So we are done with c. We need to determine a and b. So I will simply put 0 here, which is the same as f of x is equals to ax squared plus bx. Then we need to continue. We are going to use this point and also use this one. So let us start using this one. We know that order pair is x, y. So in this case we have 1 maps -3. So where we see x, we can substitute by this. Where we see y, we substitute by this. So this is y. We are going to substitute by -3. It's equals to a 1 squared plus b 1. And then from here we have -3. It's equals to 1 to the power 2. It's 1. 1 multiplied by a. It's a plus b. Now from here we can make a the subject of the formula, or you can make b the subject of the formula. So we transpose this, it becomes -3 minus b, and then we label this as equation 1. Then we move to our next point using the very same equation plus bx, and then we know that our point is 5 maps 5. So where we see y, we substitute by 5. It's equals to a, and then x is also 5 squared plus b 5, and then we have 5. It's equals to 5 to the power 2. It's 25. 25 multiplied by a is 25a plus 5b. And then from here we transpose this to the other side. It becomes 25a. It's equals to 5 minus 5b. We divide both sides by 25. We are going to have a is equals to 5 minus 5b over 25. So we label this as equation 2. Now since we look at these two equations, this one and this one, you can see both of them, the subject of the formula is a. So we can simply say equation 1 is equals to equation 2. Then we equate the two equations. So we have -3 minus b is equals to 5 minus 5b over 25. Then we solve for b. We multiply both sides by 25. 25, and also this term by 25. So this will get rid of this. On the right hand side you are left with this, and then 25 multiplied by -3, it's actually -75, and then we have b multiplied by 25, it's -25b. Then we take all the terms with b variable to one side and all the terms without the variable to the other side. So we are going to take this to the other side, and then we also take this to this side. So we are going to have -75 minus 5, it's equals to -5b plus 25b. And then from here we have -80, it's equals to -5b, actually positive 25 minus 5, it's 20b. Then from here we divide both sides by 20. This will get rid of this. We are left with b, it's equals to -80 divided by 20, it's -4. So the value of b is -4. We are left with the value of a. In this case, there are many ways to actually determine the value of a. We can substitute b by -4 into equation 1. So our equation 1 is a is equals to -3 minus b. Where we see b, we substitute by our answer. We have -3 minus -4. So a is equals to -3. Negative multiplied by negative is positive 4. So a is equals to 1. Then we can write our equation. F of x is equals to 1x squared minus 4b. No, actually 4x. The value of b is -4. X squared minus 4x. So this is the equation for f. Our next question, 3.4. A. Write the equation of f in the form of, or in the standard form of. So we need to complete a square. So this is our equation. We can actually complete a square from here. Remember the rules of completing a square. The value of a must be +1. In this case, is fine. So we can start introducing our terms. So we have plus. The value of b is -4 multiplied by 1/2 squared minus -4 multiplied by 1/2 squared. There is a lesson video on completing a square. So simply go through it and then you'll understand how we work out these terms. So the first bracket, we simplify. Inside the bracket we are going to have -2 squared, and then we actually simplify this as a whole. So inside the bracket we have -2. -2 to the power 2 is +4. +4 multiplied by negative is -4. Then from here we take all the terms raised to the power 2, we put them inside the bracket and then raise it to the power 2 minus 4. So we are done with the question. Let us quickly go to the next one. 3.4b. The graph of f is parabola since f is a quadratic function. Use the equation in 3.4 or the two formula for quadratic functions to write down the coordinates of the vertex of parabola. So the vertex is actually the turning points, or some say it's the axis of symmetry. So the vertex of the parabola is simply this terms. So we can say the turning point or the vertex, it's actually 2 maps -4. That's it for this lesson video. This is Bahula SJ. Thank you very much.